Hello everyone. Today we will see the design of connecting rod, which is an important component of IC engine. The connecting rod it is the device or mechanical machine element or component of IC engine through which we can transmit the motion or forces from piston to crankshaft. So it is the intermediate portion between the piston and crankshaft. So in design of connecting rod, the first important parameter is selection of the material for connecting rod. So alloy steel material is selected for connecting rod. So it is represented by a series 40C R1. So the material is alloy steel. Then compressive yield strength for that material is considered as a 600 Newton per mm square. So first we have to determine the cross section of the connecting rod. So let T will be the flange thickness. Also it will be considered as a wave thickness for the connecting rod. Then B is the width of flange, which is always equal to the 4 times wave thickness or flange thickness. Then H is the depth of section, which is always equal to the 5 times flange thickness or wave thickness. So this is the diagrammatic representation of the connecting rod. So it will consist of two eye ends. One is a small eye end and second one is a big eye end. So here small end bearing is there. So here we have to insert the gudgeon pin inside in this small end, that is called as also shaft end. And the second end is a big end where the connecting rod for the big end crankshaft is mounted on this at this end, and a bearing is provided for free movement of the shafts. Then nut bolt arrangement is there. Then shank or this portion is called as the body of the connecting rod. So this is diagrammatic representation of the connecting rod. So wave thickness is denoted by T. Then width of line is P, which is always equal to the 4 times T. Then depth of section H is equal to 5 times the wave thickness. So the area of cross section or cross sectional area is denoted by AC. So it is equal to the 2 into 4 times thickness, that is the width of flange, into the wave thickness plus 3 times wave thickness into wave thickness. So the cross sectional area will be the 11 T square. Next will be the moment of inertia of cross section. So it is denoted by IYY and given as BH cube by 12 minus 1 by 12 into P minus T into bracket H minus 2 times raised to 3. So putting all the values of parameters just like width of the flange, then depth of the section, then wave thickness, etc. We'll get the moment of inertia equal to 34.91 T raised to 4 mm raised to 4. This is for YY direction moment of inertia. Next, for X direction inertia, we are calculating by using the formula 2 into 1 by 12 into TB cube plus 1 by 12 into bracket H minus 2T into T cube. So putting the values of wave thickness, then or just putting the value of P and H, we'll get the IXS, that is a moment of inertia along X direction 10.91 67 T raised to 4 mm raised to 4. So radius of gyration k square yy becomes Iyy upon a. So putting the value, you will get the kyy equal to 1.78 along y direction. Then radius of gyration up along x axis will be I axis upon area, cross sectional area. So you'll get k xx equal to 0.9962 times t. So here you will get kyy 1.7816 mm and kxx 0.9962 t. So for d is equal to, that is the bore diameter 100 mm and bore length 110 mm. The total, take the equivalence length of connecting rod L equal to 360 mm. For both end are here, so we have to take L is equal to capital L. Therefore, L is equal to 360 mm. Then maximum gas pressure F max is equal to pi by 4 T square into P max. So the T will be 100 mm and maximum pressure is 3 Newton per mm square. So the maximum gas pressure acting will be 23,561.94 Newton. Then buckling of connecting rod is the plane of rotation. Therefore, NF into F max is equal to SYC into AC divided by I plus alpha LE upon KYY bracket square. So here NF is the factor of safety, F max is the maximum pressure, then this is compressive strength, A cross sectional area, LE and KYY, etc. Take alpha angle equal to 1 upon 7,500 and factor of 55. Putting all these value, we'll get the finally the equation in the form of t raised to 4 minus 17.85 t square minus 19.10 is equal to 10. By putting t is equal to t square in the above equation first, so you'll get the small t, capital T is equal to 22.21. Therefore, small t square is equal to 22.21, t is equal to 4.71. So the t is calculated as is equal to 5 mm. So the dimension of cross section of the connecting rod flange thickness t will be 5 mm, which is equal to the web thickness, which is equal to the 5 mm. Then width of the flange b is equal to 4 times t, that will be 20 mm. Then depth of section h will be equal to 5 times flange thickness or web thickness, so that will be 25 mm. So check the buckling in a plane perpendicular to rotational plane. Therefore, L is equal to 0.5 times L. So it will be, the length will be equal to 180 mm. Then along x direction, radius of gyration will be 0.9962 times t. So that will be kxx radius of gyration equal to 4.981 mm. Then cross sectional area is equal to 11 t square. Therefore, his cross sectional area will be 275 mm square. Then buckling load FCR is equal to S by C into cross sectional area. So by putting the value, you will get the buckling load 14,000, 1,40,530.68 Newton. Then available factor of safety NFA is equal to FCR upon F max. So factor of safety is 5.964. So as NFA is greater than NF, actual factor of safety design, so the connecting rod design is safe. So along Z direction, along YY direction, Z is equal to 13.97 into DQ. So ZYY will be equal to 7,152.64. So you will get the stress by using the formula. So the calculated stress value will be 97.47 Newton meter. Now we have allowable stress for connecting rods SYC upon NF. Therefore, that will be 120 Newton per mm square. So our calculated stress is less than the allowable stress. So design is safe against the bending moment. So this will be the bending stress calculated for the connecting rod. Then design of small end of connecting rod. So the diameter dp and length L1 of piston pin. As the L1 is 0.45 d, Then will L1 equal to 45 mm. Then assume PB is equal to 25. Therefore, DP is equal to 20.9439. So DP, the diameter of small end will be calculated as 21 mm. Next, inner diameter of the small end DPI is equal to DP plus 2 times bearing push thickness. So DPI will be equal to 26 mm. Then outer diameter of small end DPO is equal to we have to calculate NO is equal to efficiency is equal to L upon R, so that will be comes as a 6.5454. So the total reinforcing mass MR is equal to MP plus MC by 3. So putting MP is equal to 25, you will get so the total reinforcing mass will be equal to 3.207 kg. Maximum inertia force Fi maximum is calculated by total reinforcing mass into W square max into R into I plus 1 upon N. So the Fi is maximum is calculated as 60,444.16 Newton. As therefore allowable stress is 120 Newton per mm square, as we know. So we can get the DPO, that is nothing but diameter 37.193 mm. So by empirical relation, DPO is equal to 2 times DP. So DPO is equal to 42 mm. So now DPO becomes 42 mm. So design of big, now we will see the design of big end of the connecting rod. So the diameter will be equal to DP, DCP, and length will be equal to LP of crank pin. So LBC is equal to 1 to 1.5 DCP. So LBC is equal to 1.4 times. We will take DCP. Now, considering the pressure lubricated bronze bearing, so PB is equal to 10 Newton per mm square. Now F max is equal to LBC into DCP into PB. Therefore, DCP is equal to 42 mm and LBC is equal to 60 mm. Inner diameter of big end DCI is equal to 42 mm. Now thickness of bearing S is equal to 1.75 to 2 into DCP. Therefore, take S is equal to 76 mm. Now sigma BC, that is nothing but stress, Fi max into S divided by 4 times TBC. So the TBC is equal to TBC, it will be sigma stress 9570.32 Newton per mm square. Therefore, we get the TBC is equal to 32 mm. Next is the outer diameter of the big end DCO. It will be equal to DCI plus 2 times TBC. So that will be equal to 112 mm. Next, by empirical relations, DCO is equal to 1.5 times DCP. So that will become as a 63 mm. So by taking largest value, DCO is equal to 112 mm as it is a big end. So here we completed the design part of very important component of connecting rod. That is a small end and big end.